Okay, very good evening, everyone. My name is Sri Lakshmi Warburg. I am the TA for this course, Electrochemical Impedance Spectroscopy, and today I'll be taking the class. So, yeah, since no one has initially joined, I know last class we started with what to say. Yeah, we stopped with what to say. Yeah, the week 8 questions and answers we were solving, the assignments. So, yeah, I'll continue with that then. Yeah, so we start with the ninth question. Now, the 10th question is there. I'll share my slide. Just give me a moment. Just give me a moment. I'll just set the curriculum. So, we'll continue with the So I think my slides are visible. So I'll stop in the ninth question. So the question is to find out the polarization resistance in the above question. So the first thing is to write the impedance equation. Okay. So we know this is the case for finite boundary condition. So yeah, how to do is, you know the impedance equation, so I'm writing down that. Okay, ZA K1 DC del X. So that's the equation. So this has been we're using this from the last class. I'm not giving again a brief what to say insight into that. So yeah. So now we'll have one class the next week and winding up one more class. Totally, apart from this, you have 4 hours. So what my plan is, by today and next class, I'll finish the porous liquid, and for the last class, I'll be taking the nonlinear reacts. So I've gone through that. It's mostly what to say. It's one I can say mostly theory type questions and some problems. So I don't take much time, I believe. So, so coming back to this, so you know this is the equation. Okay. Uh, I'm sorry. Just, yeah. So I'm writing the Faraday impedance equation. I wrote the wrong one. So the Faraday impedance is given by 1 plus Q1 DC tan H j omega by dE del j omega by dA. Okay. H of j omega dB. Okay. By root of j omega dB. This is the formula, right? Like this will be the numerator by denominator. K1 DC C x equal to 0 minus, just wait, okay? I just want to see if I started recording. B minus 1 minus 1 DC CB at x equal to 0. I hope my slides are visible and I'm audible also. Okay, so now you're asked to find out the polarization resistance. So the polarization resistance corresponds to what? Omega tends to 0. Okay, so what you have to find out is ZF limit omega tends to 0. So this value is what will be giving you the polarization resistance. Okay, so what I will do is, so you can see the first term. What is the first term? It is 1 by, so basically I am dividing this. So you have 3 terms in the numerator. So the first term is 1 by f into b1 k1 dc c at x equal to 0 minus b minus 1 k minus 1 dc cb at x equal to 0. So what will happen if you are applying limit to the first term? Can anyone tell? Can anyone respond, like if we are able to, if I'm audible or not? Because I'm facing some net connectivity issues, so I just wanted to clarify that.
Yes, you are audible.
Yeah, sure, thank you. So,
Yes, you are audible.
yeah, thank you. So, the first term is this one, right? So, if you are applying limit omega tends to 0 in this first term, what will happen? There is no omega term, right? So what you will get is directly the first term. I mean, there is no effect of the first one will be same. So what you are doing is you are applying limit of omega tends to 0. In this one there is no omega. So what you will get finally for the first term, that is of the three terms, the first one will be same as that. There is no effect. I hope you understand that. Now when it comes to the second and third term, you can see there is omega term. So when you are applying limit, so yes, there will be an effect of uh, k minus 1 dc cb at x equal to 0. So this is the first term. Now the next term. So the next term is again limit. So you see this part, right? This is the denominator. Denominator does not have an omega in it. So this term is going to remain as such. So where exactly omega is going, I mean where exactly it will affect? This term, okay, and this term, right? So there is no effect on the denominator. First term will also remain as such. So I am taking the second term in the numerator. So which is nothing but this k1 dc tan h j omega t by del by root of j omega dA. Now what happens if you are applying omega tends to 0? So if you are applying omega tends to 0 directly, you have omega in the denominator. So that will directly become 1 by 0, you get an infinity. So that is not possible. I mean, that's not the way you have to solve it. So how can you solve it? I'll write in the next page. So you see this tan h, right? You have something like tan h root of j omega by dA into del. It's just nothing but sin h root of j omega dA del. That term, just I'm writing. You have sin h to the power something by cos h to the power something, right? I can write tan h that way, right? I'm just expanding it. So same thing, I'm going to write it in the next slide. So you'll get something like k1 dc limit omega tends to 0. You have a del term. Yeah. So sorry. So I'm just expanding it. Sin h root of j omega by dA. And you have root of j omega dA. So yeah, so now what I'm doing is, you can see this root of j omega by dA into del. But what I have over here as a constant is root of j omega dA. So what I'm doing is, I'm multiplying by dA Okay, and I'm also dividing by dA. Similarly, there is a del, right? So I'm again multiplying by del and dividing by del, right? That makes sense, right? So the next step becomes K1 dc limit omega tends to 0. Okay, you have sine h root of j omega by dA del cos h root of j omega by dA into del. So you see root of j omega dA. So this becomes d. This same as writing dA square, right? Root over dA square. That is same as dA, right? I just wrote it. So I'm just taking this thing inside the square bracket. So what I'll get is root of j omega by dA again. And I also have a del over here. This is similar to the expression inside the bracket. Okay, and apart from that I have this dA over here and this del over here. This is not used, right? dA by del, it's a constant. So what I can do is I can take it out, right? I hope that's clear. Now this is nothing but I'm just representing it as x. Okay, so if omega tends to 0, that means if this entire term is x, if omega tends to 0, then I can say x also tends to 0, right? Because x is nothing but root of j omega by dA into del. So if omega tends to 0, this entire term will also tend to 0. So I'm just rewriting the limit. Sin h something by cos h something. So that is something like tan hx by this entire term, which is x. So can you tell what is limit x tends to 0 tan hx by x? This value equal to, it's actually 1. Okay, so when you simplify, you
One.
are yeah, so you are getting del by dA into k1 dc. So this is for the second term. Now similarly, if you do for the second term, that is k minus 1 dc tan h something by root over something. Okay, so you'll get the same thing. So I'll do the same thing, that is I'll multiply by dB and divide by dB del and del. So when I take it out, I'll get del by and we'll get limit omega tends to 0 and I told this can be written in terms of x. So it will be again limit x tends to 0 tan hx by x. So this entire term will go into 1. Finally, I'll get del by k minus 1. Okay. So, yeah. So finally, when you do it, what you will be getting is RP means 1 plus K1 dc del by dA. Please substitute the values and find out the answer, and then let me know. So here the difficult part or the challenging part is to simplify. So you should know how to apply the limit, etc. But once that is done, it's easy. Please substitute the values and find out and let me know. I'll give you a couple of minutes and then I'll discuss.
Actually, in this bracket, should we not write B1 F into B1 K1 DC?
I didn't get you. Did you mean the bracket? Okay, F into B1 K1 DC. Yes, correct. B1 K1 DC C8 x equal to 0 minus B1. Thank you. Please do it. Then we'll discuss the answer. So we had already found out the value, other values, that is given DC, del, etc. in the previous question. So I just write down the value. Given DC equal to So from previous questions, we already found out what C at x equal to 0 and C at x equal to 0 are. So that's what I said, everything are interrelated. So we have to. Uh, can anyone tell what's the answer? Please work out. I'll give a couple of more minutes. Just cross check the values you've used and then solve it so that you don't make a mistake. So you're supposed to get an answer which is I got 6.28 ohm centimeter square once I substituted and found out the answer. Okay, this is the answer which I got. Uh, Give me a couple of minutes, like I've not added the rest of the questions. I'll do that. Meanwhile, try to solve it and get the. So I'll add the rest of the questions to be discussed also. So next is the special case, like what will happen if EDC equal to 0. So the question, like we have already done similar question. So now the thing is, we are just putting a condition if EDC equal to 0, how will it be? So are you able to get that answer? Yeah, so I was getting around 6.28 ohm centimeter square. Now we'll move on to the next question. So the next question is if EDC equal to 0 volt versus OCP, then what is the charge transfer resistance? So this one, actually, if you remember, we had done the simplification. Either you can do it directly, like just wait. So the question is, what is the charge transfer resistance when EDC equal to 0? So this was that question we did. Okay. So if you remember, this was the case when we know k1 dc, k minus 1 everything. Now what will happen when what to say edc equal to 0?
Your voice is interrupted.
Okay, are you able to hear?
It is not audible now.
It's audible now or not? Hello? Hello? Can you hear me now?
It is not audible now.
Just wait. Is it audible now? Is it audible now? Just I'll try connecting it again. Am I audible now? Am I audible now? Is it audible now? Hello? You can't see my slide, I think, right? You're able to hear me now, right?
Yes, now you are audible. Slide was also not visible.
Yeah,
Slide was also not visible now.
yeah,
Just a
I'll
few
just
minutes back.
yeah, yeah, I'm just yeah, I'll just just give me a couple of minutes. My net is actually slow, that's the issue.
is access issue.
I think now it is.
I think now it is okay.
I'm trying to reconnect to the system. Just give me a minute. I'm not sure what happened. Okay. Meanwhile, you can start doing the next question. That is, if EDC equal at 0 volt versus OCP, what is the charge transfer resistance? So if you remember, we had done this kind of question in the question number 9. That is how to find the charge transfer resistance. So in that question, we have the formula 1 by F into B1 K1 DC CA is my minus B minus 1 K minus 1 DC CBS. Now the question is, what will happen if EDC equal to 0? Can you tell me? So when EDC equal to 0, you know that. So I'm audible through my phone, right? So
Yes, you are
yeah,
audible.
yeah. So the thing is, I'm asking if ED is equal to 0, how will it affect the rate constant? So charge transfer coefficient. So it will affect the rate constant. How, K1 DC equal to K1 not e to the power B1 E. So that E is now 0. So when K1 will be equal to K1 DC and K2 will be equal to K2 DC. So and you're not applying any potential. So when you're not applying any potential, that means when you're not applying any potential, it means that there is no reaction itself happening, and CAS and CBS will be equal to that at the, what to say, will be equal to same as that in bulk. So that is the only change you will have to make in question number 9. Could you please try that? Meanwhile, I'll share my slide. Actually, I'm not able to share my slide. I'm not understanding why. Are you able to get the answer for that question? Yeah, so I just type from here if that's visible to you, and I press it on present on my screen over here. Is that okay? I think that will work better if I don't waste the time. You can see, right? question. Were you able to do that? Like what I asked. So there are two ways. Either you can substitute in that previous equation, okay, that big equation, or we had also discussed about a simplified version of that equation. So that was something like I'll just write it down. Yeah. So we had discussed about an alternative equation like something like RT equal to. So I think two classes before, I think last class, I'm not sure. We discussed on, yeah, I think two classes before, last to last class. So we discussed an equation like this, if you remember. So you can use this equation also. So what will be the value of R? R will be 8.314 joules per mole Kelvin. Joules per mole Kelvin means it will be kilogram meter square per second into mole Kelvin by mole Kelvin. So you know all the units are in centimeter, so you have something in meter square. So what it can be done? This R value can be multiplied by 10 to the power 4. So R value will be nothing but 8.314 into 10 to the power into 10 to the power 4. That will be R value. So T, the first part of the question itself says temperature is 25 degrees Celsius. So here it will be 25 plus 273.15. Okay. Now what will be F square? F square is 96,485. You know. K minus 1 0 value is K10 value is already given as 0.01, and Ca bulk value is nothing but 10 to the power minus 4. Please substitute the value and let me know what is the final answer you're getting. So what are you getting? Are you getting something like 2.6 into 10 to the power minus 3 ohm centimeter square. Okay, this is the answer you're supposed to get. Now the next question is, if EDC equal to 0 volt versus OCP.
Excuse.
Yes.
In the previous question,
Yeah.
the value of R you have just now got 8314
Yeah.
into 10 to the power 4.
8.314 into 10 to the power 4 or 8314.
8314.
Yeah.
And temperature you got 25 degrees Celsius.
Yeah. It's given in the question. continuation of seventh question.
Yes, it is given
Yeah.
if it is F Faraday constant is 96,149.
Yeah,
So we are okay.
96,485.
Yes. Okay.
Yeah. It's a gas constant value. See, no, that's not given in the question. That's a known value, right? So, like same as f value, it's not given, right? See, either you can do this way, or there's a simplified version. I'm not sure if I've when did I discuss that. I can show you. If it is. Yeah, we found out this equation, right? After that, we are discussing a case where, yeah, so yeah, I've said over here, I think last to last class. So this how it comes. I'm giving a case where EDC equal to 0. In that case, K1 DC will be nothing but K1 0 E to the power B1 EDC, where EDC will be 0. So you will have K1 DC equal to K1 0, K minus 1 DC equal to K minus 1 0. CA at x equal to 0 will be CA bulk because there's no reaction happening. CB at x equal to 0 is again CB bulk. So all this I'm substituting here in this equation. You have F into, so there's the denominator, you know, there's a total resistance to charge transfer equation. So as I told, either you do this one itself. So when I was solving F for difference, I just tried, I was getting the same answer in both the case. So either you go for this same equation, okay, and you can have CA at x equal to 0 as CAS, sorry, at this as CA bulk. CB at x equal to 0 will again be CB bulk. You have K1 DC equal to K1 0, K minus 1 DC as K minus 1 0. Either you do it like this, okay, or else you found out all this, right? You're substituting back in RT equation. So this one, B1 equal to alpha F by RT. That's also known. Ah, yeah, that's not there in the question. I just wanted to remind you, like, in case if you did not understand how I got that equation, I just wanted to show that. Yeah. So yeah. So either you can. So that's what you. Either you can use this last equation that we got over here, or you can try with this equation also. It will give the same answer. I did both. This one also will give the same value. So I. So yeah, both the ways are okay. So that's how I am getting the answer. So now the next question is, what is the polarization resistance? So polarization resistance is same as before. The only difference is, so you have this equation, right? Writing down. question. Now what will happen? Same as before. K1 DC will be equal to K10. K minus 1 DC will be equal to K minus 10. Del value is known, DA value, DB value is known. Yeah, B1 value you can B1 value is given in the question. Question number 7 you can look into. K minus 1 DC is known. CB and CA. What are all this? This CB bulb and this is CA bulb. So please substitute all the value and let me know. I'll give you a couple of minutes.
Your slide is visible now.
Ah, yeah. So now the slide is visible, right?
Yes, it is visible.
I'm not sure what happened before, so that's why I stopped. So I didn't want to interrupt the class, so that's why I was using my phone camera to just capture what I was showing the screen. I think again it went. Right? I'm not sure what happened to my net today. It again went right. I'm not sure what. Okay, anyway,
Maybe I'll.
it's coming and going. So, are you able to do that question? Are you able to get the value? So you're supposed to get a value which is. So I think this question was also marked as wrong. The, I think I faced the net issue. Okay, I've kept my video also off so that there isn't any net issue now. So answer is in mega ohms per centimeter square. So I'm writing like this. Okay, so it is 5.47 into 10 to the power minus 7 mega ohms per centimeter square. Okay, so yeah, that's the value I'm getting. Please try it out. Okay, so now the next one and the other one, it's corresponding to semi-infinite boundary condition. So we'll discuss that last derivation also, corresponding to semi-infinite boundary condition. How is that approach? We'll look into that, and then we'll discuss the questions also from that part. So in semi-infinite boundary condition, so we say that what you have the boundary layer thickness corresponding to infinity. So in this case we are saying that EDC value is equal to 0. Basically the thickness of the film is such that it isn't promoting much reaction, so we assume that EDC value is 0. So it is with that assumption that we are moving on to solving this equation. So basically, if you see the questions also, they'll be saying ETC value tends to 0, and then we are doing. So I'll give just a brief hint on like summary kind, because I want to also try to start the porous electrode thing today, so that in the next class we can start discussing about the porous electrode. And I think I've finished discussing almost all the assignments except assignment 1. So there I wanted to also discuss one question related to the equivalent circuit model. So that we hadn't looked much. I came across an interesting question. So that part is also left. Either I'll finish this part today and I'll discuss that question, or vice versa, and start the porous electrode next class. Something like that I'll do. Okay. So yeah, here. So the reaction remains the same. Okay. That is, we're talking about the simple electron transfer. Okay. So how is the IF value coming? Can anyone say? So it's been like the current density. Can anyone tell me? We have been discussing so much. So basically, the only difference comes with the, what to say, in the values corresponding to the boundary condition. That's the only difference which is happening. Everything else is the same. Can anyone tell me what is the current density? So though this seems to be like a derivation, I mean you can expect a question like where you are asked to. You might obviously you can't derive the what to say, the equation for your exam, but you can expect one question like what is the right what to say the right expression for uh, current density, or how will the concentration term be, or something like that you can expect. So even if you don't know the derivation exactly, like how to proceed, you should know like what are the each terminologies and etc. So for that equation we need to know what is K1 DC Yeah, it's visible, right? Okay, next one please. And plus B1 easy. Okay. So what is the next step? The next step is to write the IF equation as a function of concentration. So although the same as what we did in the previous derivation. That's why I'm doing it fast. I'm not explaining much. If in case because we are lacking time also, we have only two more classes left. Okay. So if any doubt, you can ask me. Okay. So we told that IF is a function of the potential, the concentration of A, concentration of B, and we are independently, what to say? We are independently trying to differentiate with respect to everything. Okay. DC. Please, what to say? Even if you, as I told, you don't have to by heart the derivation, but in case you can expect a single step, you can be asked like how IF is dependent on potential and concentration, how will you differentiate or something like that. So in that case, you need to know the concept even if you don't know the derivation. So that's why I'm showing you the derivation. So this how it will come, and then has the slides gone again? Okay, I'm again facing some net issue. I'm not sure like why that's happening. There's some fluctuation in the net over here. So again, I'll start. So meanwhile I'll try to fix it. But till then, I'll just try to share through my mobile like how I'm doing. So that's visible, right? The slide is visible, right? Yeah. So the next step is to find out. Sorry, could you please tell once again? Hello, you can hear me? Oh, okay, sorry. My mic was mute. I didn't notice that. So I was telling something happened to my net again, and it's gone. So by the time I fix that, I'll again share through my mobile. Okay, actually, I'm out of my college, so that's why I'm having net issues. Anyway, for the next class, this will be fixed. Today, you will have to adjust. So yeah, so the next is to find out del CA or DCA and del CB. Okay, so del CA is nothing but CAC. So all this we have seen, just giving a recap because there isn't much difference. CAC not e raised to j omega t e raised to phi. Okay. Yeah, e raised to j omega t. Yeah, that's how you'll get for del CA. Now, what you can do is del CA by dou t. So this already known. We'll substitute for what is a CA in terms of CA bar e raised to j omega t, that one. So this part is already done, and if I simplify it, I'll get something of this form. Okay, then you get an equation like this, and you know the solution for this is of the form CA bar equal to C1 e to the power mx C2 e to the power minus mx. Okay, then but what is the boundary condition? So at so we know what are the boundary conditions. That is the next thing. So we already know at the surface what is the boundary condition. The same as that discussed before. Can anyone tell? You have two boundary conditions. One at x equal to 0 and another one at So I'll write that. So x equal to 0, you'll have a boundary condition where okay, this will be the first boundary condition. Sorry, this is at del. That is towards the outer where it is meeting the bulk solution. Okay. I'll just check if the net is getting connected also. Uh, just give me a moment, then I'll just log into that. Actually, I'm facing some net issue. I'll go on with this itself. Yeah. So one condition is at x equal to del ca bar equal to 0, and at x equal to 0, because of the time limitation, I won't be deriving the entire part. Okay. But I'll show you the major parts because I want to start the porous electrode today. That is the next one. We are lagging a bit. So this is the condition, flux condition, which says the net current is equal to the flux of the material also. So, so this condition we have. So what has to be done next? You will have to substitute that and find out what is dou Ca by dou x and how to simplify after you apply this first condition. So once you apply this condition, you will get something of the form. Please try this out. The same as the last one, except that the boundary condition changes. So this becomes the first one, and for the next one, when you substitute this one, you'll be finding out the first one dou Ca by dou x. Okay, when you do it, you'll get something of the form C1 and so you'll get something like this. You will have to substitute this in this given above equation. Okay, then you will find C1 and C2. Okay, finally you will get del CA. Because of the time limitation, I'm not showing you the entire derivation. I'll just write the, you'll get del CA at x equal to 0 as something like minus del IF gem del. Similarly, you'll also get at x equal to 0, you'll get something of this form to both del CA and del CB, both in terms of del IF. So now what is the next step? You will have to substitute for in this equation. You have IF equation, you can differentiate with respect to E, CA and CB. We have done that before. So you'll get the equation for dou IF by dou A, dou IF by dou CA, dou IF by dou CB. Similarly, D we know, so DCA and DCB we are expressing in terms of IF. Okay. So when we take that side and we'll take all the terms with IF together, we'll have the one term with E and then we'll take it down. So finally, we will get the expression as, sorry, numerator is b minus 1. Okay, okay, you're not able to see. I'll cancel it like this. It's visible, right? So it's same as the last one, but because of the time limitation and the net issue, I'm not deriving the entire equation. We had done the same. It's the same as the last case, the finite case. The only difference is the boundary condition. Okay. like if you want to try out, please, I've given you all the steps. So in case you are interested to try out, please try out. And you get stuck somewhere or anything, please let me know. We can discuss about the same in the next class then. Yeah, so you get an equation like this. So finally, just give me a minute. So finally, I can write this at x equal to 0. So this is the equation. 1 plus k1 dc tan hm del by root of j omega dA plus k minus 1 dc tan hm del by root of j omega dB by the whole divided by f into b1 k1 dc c at x equal to 0 minus k minus 1 dc b minus 1 cb at x equal to 0. Okay, so this is the equation for semi-infinite boundary condition. Now, in the above case, that is this is the continuation of question 7. So the question is, in the above case, if at EDC equal to 0 was OCP, but with semi-infinite boundary condition at a frequency of 100 Hz, calculate the Faraday impedance, the real part of ZF is. So how will you proceed with this question? So for this question, if you are doing, you need to use Excel or MATLAB, because by hand doing this is not possible. So if you see this part, the impedance equation is something of this form. So you have omega coming over here, right? Here this m also has omega term associated with it. So it is not possible for us to by hand, segregate the terms. So when omega, omega comes there in those terms. Again, j is there in the denominator, that too to the root power. So it is difficult to segregate by hand and do this. So what can be done is you can either use MATLAB or Excel. You'll have to feed the entire equation, substituting the value of k1 tc, k minus 1 tc. Okay, then omega value frequency is given as 100, so this one will be 2 pi f. So f value is 100, so that will be the omega value. D and dB are known. K1 dc, k minus 1 dc, here it is told that etc equal to 0. So k1 dc and k minus 1 dc will correspond to k1 0 and k minus 1 0. C at x equal to 0, CB at x equal to 0 will correspond to the bulk solution values. What you have to do is feed this into Excel sheet or a MATLAB, substitute all the values and just run the equation. That is, you type the set of equation and press enter if you are doing in MATLAB. So in that case, you will get both the real and the imaginary part separately. Just give me a second. Yeah, yeah, I got excited. Sorry. So either you'll have to do it in MATLAB. Sir, have you tried the MATLAB or Excel before? So yeah, so to solve this question, that's a huh? Okay. So are you able to solve this in MATLAB, Excel, and get the answers? Okay. So could you please tell the answers? What you got for the real part and imaginary part? This question. Okay. Okay. No. Like. Is this one also marked as zero mark? I'm not sure. If you could take the assignment and check. Is mark allotted for this question? Just give me a moment. Yeah. So yeah, but while what to say, and marking, it's given as 0 points. So that can be because of the error in the value. So you see, it's 0 point, 0 point. So when I'm solving, so for the real part, I got the values around point 0.514 ohm centimeter square. And for the imaginary part, I got point 0. So these are the values which I got for this question. Okay. So quickly before starting the porous electrode, yeah. So now what we are going to look into is the next part. That is okay. Either we'll discuss assignment one and come back then. Yeah. So I mean assignment two. So this is the last assignment that's left. Now onwards, porous electrode and the nonlinear gas electrode. Those assignments are left. That's all every other assignment. Okay. So yeah. So if I cover that non-linear. So like we have two more classes actually. Next week Tuesday we'll have a class, and I've also requested for one more class. So I'm not sure like if a mail has been sent to everyone regarding that. So in that case, if we get that extra class, it will be well and good. We can finish off non-linear EIS also. But I think non-linear EIS is mostly like theory-based question, right? Instead of problems. So that's why like I've kept it for the last. I mean, is there mathematics? Okay, fine. I'll check into that. Like, yeah, so we have two more classes. Yeah, after that, I can help, I guess. Okay. Yeah. Sorry. Okay, like that. But as per the, I think after that, exam will start, right? Like, I think. Okay. Okay, I'll check that and I'll let you know. So if time permits, I'll surely explain to you, sir. But I'm not. So that's what. Some people have asked for derivation. Some ask for the numerical. To us, actually less enough. Like there are so much to discuss, right? Derivation also. Once I'm doing what sir took in for us, it's difficult to compress that to 2 hours and take, right? So that is why time limitation is the issue. But I'll try to complete the maximum as possible. So that's it. I'll discuss few of the theory questions now, so that in the next class I'll directly go to assignment. I think what is that assignment? Assignment 9. Yeah. Then after that, yeah, assignment 9 and sorry, I think assignment 10 is the next one after that. So that we'll do in next class. Then 11 and 12 also, if I get one more class, we'll discuss that. Okay. So lock-in amplifier uses which of the following method to calculate the magnitude and phase of the signal? So it is cross correlation. Okay. So we had already seen it in assignment 2. So what is FFT, cross correlation, etc. So it's cross correlation that uses the that's a method which is used by lock-in amplifier. Now for the batteries, it's common to use which one? Odd harmonic random phase multisign, odd harmonic Schroeder phase multisign, pseudo galvanostatic, pseudo potentiostatic. So the answer is directly pseudo galvanostatic. So we had already discussed when the magnitude. So that's because it's of the form E equal to Zi. So if my amplitude is small amplitude of current is given, it will be in some power of 10 to the minus 3 because it's milliamps, and the impedance will also be low. So overall this value will be low. Instead, if I give the perturbation of potential, because the impedance is low, that entire value will become big and the current value will be so high, it will be difficult for the equipment to maintain that. Now the next question is kinetic effects manifest mainly in which of the EIS area. So the kinetics is in the mid and low frequencies. High frequency you get to know more on the double layer capacitance. Choose the correct option. Higher harmonics can arise. The option one if the system is non-linear. The next option if system is linear. The next option is if the system is linear but a DC bias is applied. Next option is if the system. So if you remember, there will be EAC naught square, EAC naught cube, those terms. So basically, it is not linear. I mean, that is the option actually. I'm sorry. So when the system is not linear, sorry, not this option. So what we expect is like if the system is linear, you will have something of the form A plus BX form output. But if the system is not linear, so x is the input in this case. You will have bx plus bx square, bx cube, many powers. So it is difficult to segregate the terms and say like if I give a sin x input, my output is cos x or something like that. It's difficult to say because you'll have it two different powers of that input. That's the idea behind that. Now the Taylor series expansion of e to the power a sine theta is given by, so we know e to the power x equal to 1 plus x plus x square by 2 factorial x cubed to the 3 factorial and so on, goes on. So here it will be a sine theta, right? So it will be 1 plus a sine theta plus right. If the signal frequency is 3 hertz, then to acquire 5 cycles it will be 5 by 3 seconds. Okay. Now the next question is, in FFT analysis, the number of harmonics that one must measure increases when, sorry, in FFT analysis, the number of harmonics that one can measure increases when measurement duration is longer, sampling frequency is more; measurement duration is shorter, sampling frequency is less. When sampling frequency is more, so the answer is sampling frequency is more. That means the number of frequencies at which the data collected is more, we are able to get more number of harmonics. Okay. Sorry. Yeah. Consider two sine waves of frequency. Yeah, this one I did. Consider two sine waves of frequency f1 equal to 1 hertz and f2 equal to 2 hertz. Which of these integrals will give non-zero values? So in this case, you will see this. So you see this sine a. So it is to sine 2 pi f1 t into sine 2 pi f2 t. So when both are different, this will give you a zero value. So that's the formula. Same way here also, irrespective of the range, it will give you 0. So this one is nothing but sine square 2 pi f1t, which can be written as 1 minus cos 2 into 2 pi f1t. Sine square t can be written as 1 minus cos 2x by 2. This is the concept which is used. So B and C will give us non-zero value. Okay. Choose the correct option. To improve the signal to noise ratio, we can increase the amplitude, average the many number of cycles, both of the above, none of the above. So we know when we increase the amplitude, we are reducing the noise effect. So this one is correct. Average the many number of cycles. So when we are averaging over many number of cycles, those noise which is also involved is getting reduced. So many cycles which have noise, when you are averaging over it, the noise will reduce. So both are correct. So both of the above is answer. So this one I would like to give as an homework. So yeah, so this one is similar to, so there's not an assignment question, but when I came across it, I thought I should discuss in the class. So this is something like the equivalent circuit. So we know that, so I can just first I'll read the question. Consider the following circuit given in one. So it's given that R3 equal to 1000 ohms, C3 equal to 100 microfarad, R4 equal to 250 ohms. So that is the values of all the elements in this circuit is given. Okay. Now you have to find out R5, R6 and R6. So how to do? So the first one will be omega tends to 0. You will do simplify both the circuit. So you know that both are equivalent circuit, right? That means the impedance predicted by one of the can be modeled by the other one also. They can be used interchangeably. So what you can do is you can simplify the circuit using omega tends to 0, omega tends to infinity. Simplify, you will be able to find R3, R4, I mean R5 and R6 from there. Now how do you find RC6? So C6, what you can do is, that's a homework part. You can try it. I'll give you the idea. So the net impedance from this, you know, both are equivalent circuit. That means instead of this one, I can use this one. Instead of one, I can use two, or instead of two, I can use one. So why are we able to use this impedance, which is predicted by the circuit one, will be equal to the impedance predicted by circuit two. That is the total impedance. So both this can be used interchangeably. Okay, so what you have to do is you have to solve the first one. You know all the values, you'll get an expression for every values are known, you'll get an answer, right? Then after that, again, you don't know C6, you know R5 and R6, but you will again solve, you'll get an equation for C6. Both are equal, so then you will have to equate and find out C6. Okay, so that's how you will have to do this question. Please try this. We'll discuss it in the next class. So yeah, is there anything else? So now after this, we'll be moving on with. So after this, we'll be moving on with CP. That is CP behavior. So every case you cannot be modeling using the double layer capacitance. Pure capacitor cannot be used. Instead, we'll be using constant phase element. So when are those cases? So basically when the surface is rough or the electrode is not smooth enough and there can be roughness, so different energy levels can be there at each point, and that's why CP behavior arises. Then we also have the two models which are used, that is Sue and Manfield and Bragg model, right? Based on that, we have some problem and assignment. The next assignment, that is assignment 10, I guess, right? So that's easy to solve. Basically, you have the porous electrode model also coming up. So I'll discuss that and finish with that in the next class. So is that okay? So that's what. So this one is a homework. That is finding out the equivalent circuit model. That we'll do the next class. We'll finish wind up with CP and porous electrode next class also. Is that okay?
Yes.
Okay, fine. Then we'll stop today's class. We'll meet on next Tuesday.
Yes, and I expect that sir has explained 7 reactions that I couldn't understand
Okay,
properly.
yeah, yeah. So
Maybe
that's what I've requested for one more class. I'll try to wind up everything in that two classes. Okay. So either I'll skip the derivation, I'll directly move to the problems and thereby try to finish it. Okay. Anyway, I'll finish it. Don't worry. Okay
do you
then.
have idea what kind of question can be come in examination means final examination?
So yeah, final
Maybe
examination.
try for something different.
So final exam, you can expect some questions of this kind, like equivalent circuit model. You'll have to solve and find out those kind of questions. Theory-based questions can come from the first two part, mainly based on like where do you expect to the kinetics and what is sampling frequency and where do you expect that single sign, multi sign, etc. You can expect theory-based questions, sampling based on sampling frequency, harmonics, etc. Then moving on, you will have the reactions basically. So yeah, then you can expect questions on Maxwell elements, ladder circuits. So there basically you can expect equivalent circuit model based questions, like the one which I have given as homework now. Any kind of such question can be expected either based on capacitor model or inductor based model. Yeah, then yeah, then we start with mechanism, right? So you can expect questions with only kinetics, then kinetics with mass transfer. You can either expect those type of question where with one or two reaction intermediates, not more than that I'm expecting, because time limitation is also there, right? So yeah, either you can be given multiple examples like for this mechanism, what can be the current density or what is the impedance. Anyways, one or two questions based on the impedance, like you will have to solve and find the impedance. So basically, it will be a balanced exam. You can expect questions based on theory also. So theory questions will take less than 30 seconds to solve. So you can expect lengthy questions at the other side where you are expected to derive the equation, find out the impedance equation, etc. Right? Then those kind of questions can come. Then finally, yeah, again mass transfer also numerical based questions of the type which we've solved in the class. Assignment based model questions can come. You will be expected to find out the polarization resistance or charge transfer resistance, current density, or when the potential value will be either zero or at any other value. Again, finite boundary, non-finite, semi-finite boundary conditions. You can expect those questions. Yeah, so these will be the questions. You will have derivation kind questions. You'll have also numerical based questions. So basically, we'll have to go through everything. I cannot say in specific this will be the region which will have more number of questions or something like that. Please go through the assignment questions clearly. Try to solve. I have solved everything actually. So please go through the videos. Or I hope you have already know you are attending all the class, so you should be having the solutions. So similar questions. The reaction mechanism will be different. Something like that. Okay. Okay then. Thank you. We'll meet the next week. Thank you.